All right, so this next lesson, we're going to be solving a system of linear equations, but this time we're going to use a method called substitution. So in the previous lesson, we solved a system by graphing. All right, so that was kind of like a visual method where we'd graph one of the lines, we'd graph the other line, and then where they would intersect would be the solution. All right, so to kind of visually give you the solution. This method is called substitution, and the next method, which will be covered in the next lesson, which is called elimination. These are kind of like algebraic methods. All right, so we're going to use kind of algebra to solve these systems. All right, so in this first example, we're going to solve this linear system. Again, it's a linear system because the highest power of x and the highest power of y is 1. So even though there's no 1 written there, it's implied that this is the x to the first power, y to the first power. And it's also a system because we have two equations and two variables. Okay, so when it comes to substitution, our first step is basically to take either one of these equations and isolate a variable. So I'm just going to write step 1. We're going to isolate a variable in either equation. All right, so and it doesn't matter which variable you isolate. You can isolate the x, you can isolate the y, but you can isolate it. You just want to isolate a variable, right? So in this case, we actually have like 4 options. We have the x and the y in the first, we have the x here and the y in the second equation. We can isolate any one of those 4. Now, looking at these equations, though, it probably makes the most sense to isolate the y in the second. Right? The reason for that is notice that there's no number here in front of the y, so that we don't actually have to divide through by anything. That makes sense. Right? So if I had to choose between the 4 things to isolate, I would choose the y in the second because there's no number from the y. So in other words, it's like a 1. But if we were to isolate, we don't have to divide through. Whereas for the other 3, we'd have to divide through by the 2 if that's the case. 4 here, 4 there. All right, so enough said. So what I'm going to do here is just write out the second equation. So we have 4x plus y equals 5. And to isolate the y, the 4x here, we just need to move it over to the other side. So the y is going to equal 5. Now the 4x when we move to the other side is minus, right? Changing the sign, so negative 4x. Okay, so if 4x plus y equals 5, then y is going to equal 5 minus 4x. All right, so once you've done that, the next step is to plug in, or in other words, substitute, into plug in or substitute into the other equation. All right, so what that means is that here, right, we chose, I'll just label this 2 here. So this is equation 1, equation 2. So we took the second equation, isolated the y. So now what we want to do here is we want to take this y equals 5 minus 4x. And basically what we're going to do is we're going to plug it in for y here into the first one. All right, so it's always got to go into the other equation. So it is going to look like this here. We've got 2x minus 4. Now, instead of writing y, let's sub in here 5 minus 4x. All right, so since we found out that y is equal to 5 minus 4x, I can plug the 5 minus 4x into this y right here. Okay. And so this is, just to complete this equation, 2x minus 4, y equals 7. So this is going to equal 7. All right, so again, I want to take a second there just to kind of see exactly what happened here. We took the 5 minus 4x, which we got from the second equation, replaced the y in the first equation with that expression, 5 minus 4x. All right, so what you'll notice now is that we no longer have a y variable, right? We just have x's. So we should be able to actually solve this equation. All right, so to do that, we want to expand out the brackets. So we're going to distribute in the -4 to the brackets. Okay, so I got 2x. The -4 times 5 is -20. -4 times -4x is positive 16x. Is equal to 7. All right, and then we can collect our like terms. So the 2x and the 16x is 18x. And then I'm also going to take the -20 here and move it over to the other side. That would be plus 20. So 7 plus 20 is going to equal 27. So 7 plus 20 is 27. And to solve for x, we're going to have to divide both sides by 18. All right, so the 18s cancel. X is going to equal 27 over 18, which actually reduces, because I can divide both the top and bottom by 9. This reduces to 3 over 2. Okay, so x in this case is going to equal 3 over 2. Now, when we're solving a system, we also need to find out what the value of the other variable is, right? So the y. Right, so step 3 is we need to find the value of the other variable. And the way you're going to do this is by substituting the answer, or substituting the answer found in the previous step, answer found in step 2, into the equation found in step 1. All right, so that's pretty wordy. It's probably just makes sense just to see what's exactly going to happen. So if I scroll this back here, in the first step here, right, we isolated the variable in the second one, and we came up with y is equal to 5 minus 4x. So we're going to actually use this thing here to actually get the value of y, right? Because in the second step, we actually found the value of x, which is 3 over 2. So if I plug 3 over 2 in here for the x, it should give me the y value. So let's do that. So again, y equals 5 minus 4x. Well, we found in step 2, the previous step here, that x is equal to 3 over 2. So we want to just work this out, and we should get the value of y. So y is going to equal 5 minus, now this is the same as 12 over 2. Now, actually, before I do that, I just realized that we can reduce this now. So that 2, the 4 reduces to 2 over 1. So this is going to equal 5 minus 6. Which y is now going to equal -1. So, yeah, so y is now equal to -1. So now we can actually answer as an ordered, what we call an ordered pair, right? So x and y. The x was, what was it, 3 over 2. And your y value here is equal to -1. So this is the solution. All right, cool. All right, so that is the answer. Perhaps, actually, you know what? Just out of curiosity, or just to check our answers, I'm going to check this by using the method we learned in the last lesson, is by graphing. Right, so I'm just going to pop up Desmos, and I'm just going to do this fairly quickly. Right, all I need to do is graph each one of these. So I'm just going to highlight this one here and plug that one in. So there's the line, right? The graph of the first line. So take the second one here. plug that in here. All right, so here's my two lines. They intersect right here. 1.5, -1 is the point of intersection. And that's what I got here. All right, so 3/2 is the same as 1.5, right? So I got 1.5, -1. All right, so again, it was just confirmed here with the graph. Cool. All right, so my next example here, this has to do with, kind of application. So first thing we want to do here is kind of translate this into a system that we're going to solve the system. All right, so Alexia invested $1,800. Part of it at an annual interest rate of 3.5%, the rest of it at 4.5%. After 1 year, the total interest earned was $73. How much money did she invest at each rate? Okay, so first thing you want to do here when it comes to setting up these systems is to figure out what you're trying to solve. So in this case, you're being asked to find out how much money she invested at each rate. Okay, so what I'm going to do here is just kind of assign the variables. There we go. Good. All right. So, so going back to what I was saying, how much money did she invest at each rate? Okay, so that's what you're being asked to do. Okay, so I'm just going to assign the variables to what they mean. So we're going to let X be the amount invested at 3.5%. And we'll let Y be the amount invested at 4.5%. So that's the other. So that's what you're being asked to find, right? You want to find the value of the amount invested at 3.5%, and the value invested at 4.5%. Okay, so she invested $1,800. Okay, so that's how we're going to come up with the first example or first equation. Is the total invested was $1,800. So if I take the amount that was invested at 3.5%, that's X. I add it to the amount invested at 4.5%, which is Y. That should total $1,800. So we're not worried about the interest earned yet. We're just worried about the total amount that was invested. Okay, so total amount invested was $1,800. So if I take X and add it to Y, that's going to be $1,800. All right. So now the second part has to do with the total interest earned. Okay, so the total interest earned was $73. So somehow we got to come up with an equation that's going to equal 73. All right. So the key thing here is that if I take the amount invested at 3.5% and multiply it by 0.035, this number here, or whatever this is, should give me the amount of interest. Right? So for example, if I invested $100, I would plug in 100 for X, and I would have to multiply by 0.035 to get 3.5% of that. That would be the interest. Right? So you may have to play that, what I just said again. All right, but basically this is if I take 0.035 multiplied by the amount invested at 3.5%, this here would give me the amount of the interest. Likewise, if I add it to 0.045 of Y, that will give me the amount of interest earned at 4.5%. And if I add the two interests together, that's a total of $73. Okay, so these are your two equations. Now, one thing you'll notice is that, so now we got decimals, right? Got decimals in the second equation. What I want to do first here is actually just get rid of the decimals. And since these are equations, the way you do that is whatever you do to one side of the equation, I'm just going to do it to the other side. So basically, I'm just going to multiply both sides by, and if I want to move this decimal place 3 places, I'm going to have to multiply both sides by 1,000. All right. Okay, so when I do that, basically this decimal gets moved 3 places. So it's going to be 35x. And likewise, if I move this one over 3 places, that would be 45y equals, now on this side, I actually got to make this as 73,000. All right, because the 73 is being multiplied by the 1,000. Okay. So yeah, so this equation is equivalent to the one that I just came up with. Now we're just not dealing with any decimals, which is good. All right. All right, so now if I want to solve this by substitution, go back to my 2 equations. And basically what I want to do is I want to isolate a variable. And it's probably pretty obvious that I want to use the first equation here. And isolate one of either the x or y. It doesn't matter which one you actually isolate. Right? So here. All right, so if x plus y equals 1800, you know what? Let's isolate the x. I'm going to move the y over. So x is going to equal 1800 minus 1. Okay. So then once I've got that, what I want to do here is take this equation, plug it into the, a lot of arrows going on here, but plug it into the second equation for the x. Okay. So the way that's going to look here is when I do this, we're going to end up with 35 times, and so x is 1800 minus y. I'll write that in there. 1800 minus y plus 45y equals 73,000. All right. All right, so we need to solve for y. Notice that there's no x variables here, which is good. All right, so I'm going to multiply the 35 in. To do that, I'm going to need a calculator. So 35 times 1800. All right, so we have, we have to have 63,000. So this is 63,000 minus, okay, so let's, 35 times negative y is negative 35y. We have plus 45y equals 73,000. Okay, so the 63,000, I can move it over to the other side. So that would become negative 63,000. All right, so over here, 73,000 minus 63,000 is 10,000 equals. Now, negative 35, I can combine these two here. Negative 35y plus 45y is positive 10y. All right, so to solve for y, divide both sides by 10. Therefore, it's down. Oops, what happened there? There we go. Okay, sorry about that. Okay, so yeah, 10y, divide both sides by 10, y is going to equal 1,000. Okay, so that's the value of y. To get x, we're going to take this and plug it in here. Right, so x is going to equal 1,800 minus, and our y value here was 1,000. X is going to equal 800. All right, so those are our two values for x and y. If I scroll back here, x was the amount invested at 3.5%. Y was the amount invested at 4.5%. So to answer the question, this means that, therefore, $800 was invested at 3.5%, and $1,000 was invested at 4.5%. Go. All right, cool. So that's it. Yeah, so that's solving by substitution. All right, so again, you're taking one of the equations, isolating a variable, basically plug it into the other one. All right, cool. That's it.